Hi, in this tutorial we will be learning how to shatter animated objects in Houdini 17.5. Alright, so let's get started. In Houdini, let me switch over to my preferred desktop. Yeah, this is the way I work. So let's have our animated character, test, geometry Craig, and just to make sure that everything is at its 0th position. So I press P to add the parameters there. Uh, let's have this revert to defaults and everything goes back to 0. We don't want hammer just for this demo purpose, so exclude the hammer here. So this is taking a few steps, and just after a few steps, say after 36 frames it should collapse. Everything is fragmented and it should collapse. First let's unpack it so I get the full geometry. Now, just in order to fragment it, I am going to use the one knife fracture at the moment. So, for one knife fracture, let me scatter some points on it, and before scattering points, let's create an appropriate volume. ISO offset. Let's create a fog volume. Fog volume. Obviously, we need to increase the samples here quite a bit. Let's make it 50. Okay, so there we are. Now scatter some points. I think 100 fragments will do at the moment. Now as I scrub the playhead, as the animation happens actually per frame, Houdini calculates these scattered points, and let me get rid of the grid and you will be able to see these points even more clearly. So you can see that, yeah, as the frame moves forward, so these points are getting jittered all over the places. So it's best that first we freeze the frame, and for that let's take time shift, and I want to delete channel, and now you can see that sticks to the first frame. So now we can use one more fracture. Time shift, yes, this goes there, and this will take little time. Obviously my system is slowing down a bit because I am recording as well. So this is done. Let's check exploded view. Yeah, everything is fragmented. It's fragmented into 100 pieces. Okay, we don't need exploded view at the moment. And now we need to feed this into simulation, but where is the animation? Because since we have freezed it on the first frame, all our animation is lost, so we need to bring back our animation. We need to extract the transformation information from these pieces from the original geometry, and then we need to apply it back to the fracture pieces. So that can be done using point to form. Point to form. Yeah. So these are the points which I need to deform. When I fracture points, these are the rest points are the one that we are getting after the time shift node, and we will be extracting information from again from the rest not from the rest. We'll be extracting it from the animated geometry. So there we are. Now if we play, how will my system has slowed down quite a bit now. Okay, so I can get rid of this exploded view. Now all we need to do is to feed it into simulation. But before that, it's always good idea that we cache the geometry first. Um, we don't want all these calculations to happen at every frame and then it goes into simulation and then a lot of calculations will be happening there as well. So first create file cache. Let me copy these strings here, Control C, because I need to give a new path, and that path is going to be desktop animation demo. Okay, and in here file heap name accept. Okay, let me save this file first. Save. Let's connect it, and I don't want to animate 240 frames. I just want to animate to the first 120 frames only. So delete channel 120 frames. Okay, so now all I have to do is to save it to disk. It's getting started. It's going to take some time. Okay, so now that the file has been cached, let's bring it back. File node, point it to the place where we have file cached it, and now we can check that yes, indeed this is playing, and this is playing smoothly, so it's good. All we have to do now is to feed this into simulation. So packet first, assemble saw. Now just feed it into our simulation.net, and let's dive inside. Create all the information here. We need gravity, and we will need ground plane as a collision geometry. So let's take a ground plane. This ground plane will obviously be static object, so add a static solver to it, and then we need to bring our pieces here which are going to be simulated. So let's bring our rigid RBD packed object. This is going to be the first context geometry. So let's move one level up and connect the incoming pieces, the pieces which need to be simulated, to the first input. And now we need our solver, rigid body solver. Let's connect it here, rigid body solver. Let's merge the ground plane and the objects to be simulated. Another thing, I don't want the simulation to be affected right away at the first frame, so I just want it to be active only at the 36th frame. So check override attribute. We want these attributes to be created then. So let's create the attributes. Attribute create. First attribute will be obviously animated. Value will be 1. Another attribute is going to be active, and we want to activate this simulation only at the frame 36. So $f, it is greater than or equal to 36. Now let's test our animation. No, nothing happens. I need this. This needs to be an integer value. This point. This is not float value. This is an integer value. Let's check again. This time it should work. Yeah, on 36 frames. After 36 frames, everything begins to fall. But what about the animation? This is supposed to take a few steps forward, and then at 36 frames, they should just every piece should fall. Because in Houdini, once the object is packed, .NET doesn't seem to understand any of the animation, any of the transformation that's coming before the object has been packed. Uh, so somehow we need to get that information from animated pieces, and then we will have to apply it back into this packed object. So for that thing to happen, let's first freeze this time shift node. Let's extract the transformation information, and now let's apply this back to the back pieces. So transform pieces. The fragmented objects that you need to transform are these assembled pieces, and the information required is coming from here. So let's add it before attribute create. And yeah, everything seems to, no, sorry, let's highlight this. The reasoning, first of all I need to gather the information from pieces. Okay, so animation is happening. Let's see if after frame 36 everything falls down. Okay, and it breaks, everything falls down as expected. So there we are, everything works fine. Okay, so the animation is coming here fine, but just in order to speed up the process, it would be better we somehow poly reduce the original pieces, and then we apply it back to the simulation. And for this, actually, I'm going to use the shell tool, and then I'll be taking some of the nodes from there and apply it back. Okay, so create an arbitrary object, just torus will do, and we'll let's highlight this object. Let's apply RBD convex proxy from the shelf. Select object, press enter, and it will do the work for us. It has created this nice node structure. We are interested in this convex decomposition. Let's take this out from the network structure, and we are going to apply this just before the object is being packed. There you are. Now you can see that the number of the polygons have reduced considerably. This is going to work as a proxy for our simulation. This is actually going into simulation, and later on we are going to substitute this back uh, with the original high-res geometry. The number of the points you can check, they are just 43,000 something, whereas the originally it contains some 1,10,000 points. Another thing, you can even poly reduce if you wish to. Let's make it 60%. So now if you check the number of the polygons, it's only 26,000 right now. So whereas earlier it was 43,000. Yeah. So now let's get rid of this torus thing which we have created earlier using the shell tool. Uh, but we are interested in these two nodes. These two nodes will be responsible for fetching the transform informations which is coming from low polygon objects which we have simulated, and so let's type inside top import and give it a proper path. This will point to the .NET RBD object. Let's check. Okay, this is running fine. So we do have high polygon objects getting animated. They are getting information, transformation information from low polygon objects. It's cool. Uh, what's even more interesting, you can add even greater details to the inside of these high polygon objects, these fractured objects. You can use RVD interior details. um, and just play with the settings, and there we are. We have lot more details available on the inside of the fragmented objects, and it works. Thank you.